not real thrilled with these gearbox screws. They're going to all have to be the threads cleaned up on a rotating wire brush, but the threads on them seem to have, especially this one, has some rust. I don't like that. It almost looks like something got on them that was kind of corrosive. I don't know whether it was some sort of Loctite I must have used or something, but don't care for it. I'm all set to take the gearbox off now. Take the end of the gearbox off. Usually just a little bit of tapping like that, and it should come off. It's probably sitting on some dowel pins. Oop. Whole engine's moving here. Hope you can see what I'm doing. Maybe not. Maybe you can see that better. Yeah, sure enough, there's some dowel pins in there. Been so long ago I had this apart, I can't remember. Alright, there's the gearbox, in case you want to see it. And I had to take that apart, take that off there, is I wanted to check these bearings and the condition, of course, of the gears and the teeth. Although, like I say, this oil, there's no metal chips or grindings or anything in there. I checked that careful when I drained it out, so I think that's alright. Anyways, you need to take this off to be able to get the gearbox out of there, because there's some heads of some screws that are in here that these bolts I have to take loose, and I got to get those off there. Anyways, if you want to know what's inside a C gearbox, that's it. Thought I'd show you what it takes to flip the gearbox. Some people might look at these things and not quite understand what turns the gearbox one way to the other. If you're using an inverted engine like I am, you want to have this gearbox swiveled around like that, and it's pretty easy to do. There's bolts like this that go in here, but there's 4 of them inside. You have to take the gearbox cover off and pull this piece off. So you have to drain the gearbox, pull this piece off to be able to get to these 4 bolts that are on the inside. They're all equal length, but you have to be able to get to these, and then you can swivel a gearbox. You don't need to take this gear off. This gear fits in there on a spline. There's a spline drive on it, but you don't have to take this off. To get this gear off, you need to remove this socket head cap screw that's in the middle of this and holds this to the end of the shaft, which I'll show you here in a minute what's going on the end of the crankshaft and the rubber donut there. But you don't need to take that off to swivel the gearbox, because as soon as you get those bolts out, it'll swivel back and forth any way you want. So it's pretty easy to do, but you do need to take this cover off to be able to switch it. Here you can see my yellow lines I was talking about that put the pistons even so it closes the transfer ports, and I just put them on the outside of this drum. This also shows you the gear, how the gear fits in a spline on this spider that's on the back of the rubber donut, and that gear is held by 1 bolt with a lock washer on it that fits in the gearbox itself. So that should give you an idea how that all works on the end of the crankshaft. The yellow mark here, I would assume I can show you this maybe. You can see the exhaust ports open a little bit, but the transfer ports are closed, and that's what I'm after, to keep oil from running through there so easily, to get down into the combustion chamber and my spark plugs. And that's why I put those yellow marks on there, to tell me when the pistons are in that position. I've taken off this rubber donut, which has 3 8 millimeter bolts in there that holds this rubber donut on this little flywheel. It's it's pretty easy to get off. This is the spline that drives this gear, so you understand how this is oriented on there. And most people won't ever have to do this. I'm doing it because I wanted to look at this rubber donut to see if I see any deterioration or cracks in it. Anytime you got rubber, age can take its toll, but this thing looks to be in pretty good shape. Should probably keep oil and stuff off of it. That's probably natural rubber. So I don't want to mess that up. Most people aren't going to need to do this unless they're taking the crankshaft out. And I probably wouldn't need to do it. I think I can get the crankshaft out and even leave this on there. Maybe I'll do that. But that's what you need to do to inspect this thing, to get it off, to look at it real good. But this thing, after 20 years, it looks fine to me. I don't see any problem with it. The next step I got to do here to be able to show you the modification I made to get this crankshaft out of here. Most people aren't going to have to do that. When they decarbon an engine, all you're messing around is the 4 bolts that are down inside of each one of these cylinders. But to get this cases split, I want to remove the flywheel, and I'm going to take the electrics out of here. In case I decide I am going to use that other engine, I'll just switch those parts. The flywheel, I made myself a puller for that, which is just a block of steel with some bolts. The bolts are the most important part. Hope you can see that. That's as much as thread as you want to have sticking out of there. You don't want the thread to go past what's in that flywheel. You'll see there's not a lot of thread there. If it goes past, you're going to mess up the electrical coils underneath that flywheel, so I don't want to do that. So the way this thing is made, I just made this myself out of a piece of steel, but you can buy them. They're not, you can buy them from Rotax, or you can probably buy a universal puller too, for that matter. But I put a little, I'll take it out of here so you can see. It's just a round steel ball that I'm using to push with a little bit of grease on it. A little bit more grease out of here. You put a little grease on there and that ball will stay right there, or should. There we go. Then I'm going to put this on there, and I'm going to, let's see, line the bolt holes up here so that I put a little handle on here, because that way with one hand I can work this thing. And then you put your bolts in here, and that'll hold that thing on there tight. This big bolt here just pushes on the steel ball. That's all it does. And when you tighten that off, it's going to draw the flywheel off that taper. So that's how you get the flywheel off the mag end of the engine, the Magneto end. I've heard people arguing about is this a Magneto or is it an alternator? You know, it's got different rules for flying in controlled airspace, and whether you got to have a transponder and stuff like that. But I say this is a Magneto because if it was an alternator, it controls the strength of magnetism with windings in it. This is just a permanent magnet on the flywheel that runs it, the lighting coils. So there's no voltage regulation possible using this. You have to have some other device to regulate the voltage, and it doesn't control it by doing anything to this. So I'd say that's the difference. This is what they call a Magneto because it has magnets in it, permanent magnets, and an alternator doesn't. It has a variable magnetic field, and I'd say that's the big difference. Anyways, once that's on there, oh, I forgot to tell you too, you have to, before you take the flywheel off, you have to take this nut. There's a nut and lock washer off there, which I used 1.25 inch socket, or you can use a 30mm socket. If you got one that size, you can use that. Now I'm ready to withdraw that off there. So once I get that off, then maybe I'll work on the other end. This handle will keep the thing from turning when I tighten this. Usually when you use a wheel puller, you just put tension on it, get a lot of tension on it, and then you smack this with a hammer and it'll pop whatever's on that taper. It should pop it right off there. I got it loose, but I got to figure out why. I don't want to just pull off here, but it definitely came loose from the taper. Might be the magnets are holding it, I don't know. There we go. Yeah, just the magnets. Got permanent magnets in here. So that's how you use a wheel puller anyways. Like I say, you can buy one from Rotax. There may be universal ones. Sometimes it's hard to find one where you have bolts in, or you can make your own. It's just a flat plate of steel, and drew 3 bolt holes. You can see the bolts I'm using. The holes are real loose on there. I didn't try to make it fit too precise. It doesn't need to. All it's supposed to do is put pull on there. So if you tried making it too precise, you're just overworking yourself. And then I keep it in a bag so I don't lose my steel ball, which you can get those at a bearing store. Actually, I guess I'll leave it down in there. It seems like it stays. I'll put it back in a plastic bag. But I think I'm going to try using it again on the other end if I have to take this thing off. Although I'm not sure if I will or not. But that's the flywheel right there with the Magneto magnets in it. But you wouldn't call it an alternator, even though this looks like it, but these are the coils that generate electricity. They're not the ones that control the field strength. The field strength is fixed by the permanent magnets in there. So it really isn't an alternator. They can say what they want to about it, but it's not an alternator. I'll try taking these. I'm going to take this whole works off here. Like I say, most people aren't going to have to do this unless they're going to split the cases, and then all these electrics have to come out of here. And I believe it's I got a split grommet there, I think, that comes out of there so you can get the wires out, I believe. I was right. I guess you can see that this is a split rubber grommet here, so you can pull that out. That gives you plenty of clearance to get the wires in and out. The first wire I'm taking out is, you have to take these little sensors loose. These sensors are what trigger your spark at the right time, and they're triggered by this little chunk of metal sticking out of the flywheel here. It's just the magnetic effect that makes them trigger at the right time. But we have to take those out because they kind of bridge across between the two halves of this thing. Now to remove these cylinders, which is what most people are going to want to know how to do, just to decarbonize the engine, there's just 4 bolts down on the bottom of the water jacket on each cylinder. 11mm wrench fits them. And that's all there is to doing that. But it's very important. I want to stress this. Are you paying attention? You want to keep the piston, the rings, and the cylinder matched together. The ones that came out, they got to go back the same way with the piston facing the same direction, and the rings same face up. You don't want to take a piston ring and flip it over. Some rings you can't do that to, but it's important to keep them the same way around unless you want to hone the cylinders and you know, put new rings in, that you're really, it's really important to keep the parts matched together the way they came out of there, the way it's been run. You switch parts, then you're apt to get something seize up on you or something. These parts have been worn in and mated. They call it being mated to the part that they're running in, and you want to keep it that way. The other thing is something like case halves. You can't replace one half of a crankcase. I see people on eBay selling one half of the crankcase. Well, that's no good because they're matched together. You need to have that as a set. Having one of them, that's not right. They're machined. They're put together, bolted together when they're machined, and they got to stay that way. You can't take one half of a crankcase and sell it to somebody. Not unless the person buying it don't know what the heck they're doing. But I think taking apart these engines is not that hard to do. Anybody can do it if they're a little bit mechanically inclined anyways. Really, you can get in trouble doing something like this if you don't have any experience or don't know what you're doing. The main thing is to, something like a hammer, know when to use something like that and what to hit and what not to hit, when to use force and when not to use force. For instance, this thing's sticking on the gasket here. I just bump a little bit with a hammer to loosen it up, and then I can draw it off unless there's one bolt that's still tight in there. Some of them ain't completely unthreaded yet. I think it's this one. There we go. Now, there is the cylinder and the bolts. I'll show you. You know, they're very much like these ones that held the gearbox on, but just smaller diameter. And there's 4 of them for each cylinder. And we're going to want to keep that cylinder matched to this piston. As far as the rings being stuck, yeah, they're pretty good. It's just starting to stick a little bit, the top one. Usually it's the second one gives you trouble. Yeah, the second one maybe. Yeah. It's still free, but it's just starting to stick. Yeah. Okay. Now, I think you can see how this top ring, it moves pretty easy. Both sides of it, especially, you always want to check right here where the joint is on the ring, and you see how that's free and it pops out. It's not stuck there. Now this second ring, let's see, right here, it's free and it's loose on this side, but this side of it, you see over here, this side here is kind of stuck in there. It's not stuck real bad, and probably when the engine warms up it's working free, but right now it's starting to stick right on this edge. And you'll notice that that's on the intake side of the rings. That's where they'll stick. Now if you put the piston over this way, this is the exhaust side where the exhaust port is, and you'll see that they're loose over here. But people say, well, I looked in the exhaust port and the rings look like they're free in there. I pushed them and I could move them. Well, that don't tell you what's going on the other side, and that's where they get stuck over there. And you also want to check for how much, like here you see a little bit of black, like carbon or something discoloring here, which shows this could be coming just from the exhaust bouncing back on the piston. It might not be from a leaking ring, but you want to look for something like that, particularly on the sides over here. If you see black stuff coming down, the rings could be leaking a little bit. So this one seems to have been running pretty good. I'd say for the number of hours it has on it, this thing looks real good. There's no problems with that. But anyways, I thought I'd show you that. I'm kind of shaky with this camera, but that's where you want to check. This is where your ring sticking problem is. If you go too long, if you were to run this like 600 hours or something without decarbonate, this ring might get so stuck in there that you couldn't get it out. My guess is the top ring, even after 600 hours, would come out. These are Dykes rings. They're made a little different, and they would come out. But this second ring here, if that got so tight that you can't get it out of there, then you got to start trying to pry it out of there, and you might have trouble getting it out, and you'll probably break the ring trying to get it out of there. Of course, you can always put a new piston ring in then, but the point is you're going to need to put new rings in, because those rings are going to be so stuck in there that by the time you get them out, sometimes heating the piston a little bit with a torch and warming it up, that can help to get the rings loose, because it makes the aluminum grow, and then maybe you can get the thing out of there. But that's the reason I say if you go over 600 hours, you might have to buy new rings. You might have to buy new pistons, because you might get them all nicked up and bunged up trying to get the ring out of there, and that's a real problem. Sometimes I use like a thin piece of metal, 6-inch scale or something. If I can get one side of the ring loose and try to go around the back side of the ring and keep working it around, I work a piece of metal around, sometimes around this side on the back side of the ring, to try to get it loose. But of course, when I get around to this side where it's stuck, that can be a problem, getting that little, even a pocket knife or something trying to go around there. But a real thin piece of steel, a good thin piece of steel, I don't know that I'd use a feeler gauge, but I mean something like that. It's thin, that you can push around there to try to get it to come out of that groove. But if they're stuck in the grooves, you got problems, and piston gets rid of its heat through the rings, so you really don't want to have stuck rings. That makes the piston get even hotter. So that's how most of the heat gets out of the piston itself. That, and of course you've got fresh gas mixture. A two-stroke would never work if it wasn't for the fact there's fresh gas mixture coming in the backside on the crankcase. That's all a mixture of air and gasoline blowing on that, and that helps keep them cool on the back. But then again, that can cause carbon on the backside too. So we won't know that till we get the piston off. Now, are you paying attention? Hope so. These pieces of paper that I got stuffed in here, you can use paper, you can use a rag, anything, but you want to right away, as soon as you get those cylinders off there, you should, as soon as possible, put some paper or rag in there to keep anything from going down in where the crankshaft is, because you might have trouble getting it out. You might not even notice something went down in there. Could be a little needle bearing, it could be a snap ring from the wrist pin when you get to fooling with that, and so you want to pay attention here and make sure you stuff something in this hole around the connecting rod. Oh, by the way, I was going to show you too. You'll notice a two-stroke engine, even with the hours this has on it, you see how clean it is. Everything stays clean in a two-cycle engine. The guys with the four-stroke engines, they probably never saw an engine that was that clean unless it was brand new. But that's the way they'll stay, and they have to be, because you got to have a good air filter on there, otherwise you'll get little scratch marks on the piston and stuff like that. So if you see any aluminum or deep gouges in the piston, you always get a few little tiny, scratches, some witness on there of the thing running. There's always something going through there, but pieces of carbon and so forth. But if you see any of this aluminum that's kind of gouged out, and particularly if you see any that's inside this cylinder part, then it's seized up at one time or another, or had a partial seizure, and it's always going to seize again. You've got to get that aluminum out of there. There's different ways that you can get this cylinder, put it in a lathe, and just polish it a little bit and get the aluminum off there. Use a little bit of muriatic acid. That eats aluminum real fast, and that'll help you put a little muriatic acid on a paper towel or something, wear some rubber gloves when you do it. But that would help you get deposits of aluminum off there. And then you should come polish up the piston. When you get the pistons off, polish them up a little bit to make sure that there's no high spots or anything that's going to cause it to seize again. Real important, because once it seizes once, it's going to keep doing it. Even though it may start up and run again, it's going to give you trouble. So if you've had a seizure or think you've had a seizure, you better take it apart and have a look. Just pull the cylinders off. That's all you have to do. You don't have to take anything like I've been doing with this crankshaft here. That's a whole lot more work to get the crank out of here. But I'm going to show you one of the reasons you want to have this paper towel stuff down in here. You want to take out the where to go. That's this thing here. I suppose the technical term is a snap ring, but most people, when they get it out of here, they say where to go, and that's why they call them a where to go. This is an awl is what I'm using here. It's something woodworkers use, I think, for scribing lines and stuff, but it's just a pointy thing like a ice pick or something. And I stuff it in this little slot here. You just pry on that and get under that thing. But when you do this, you want to put your thumb over the hole so you ain't the one going where to go. There, I got it, and it didn't go anywhere. Now, for getting the wrist pin out of there, there's going to be a lot of little bearings in there. So usually what I do is I just tip this engine on its side like so that any little needle bearings come out and they fall inside the piston and don't go down inside the engine. Okay, because you could get little needles coming out of the wrist pin when I push it out. You can see it moves easy just with my thumb back and forth a little bit. But still, when I take those out, I like to use an extractor on them. This is a tool that you can buy. They don't cost too awful much, maybe $20 or so, I suppose. They have different ends. It's a left-hand thread on the end of there, by the way, that fit in there, and they're going to pull that wrist pin out, and the wrist pin will go up inside here. There's two different sizes of these. Like I say, that's a left-hand thread. So this one's a little too big for that wrist pin, so I'm going to use the smaller one. And I'll put that by running this through there like so. You got a rod you put through the center of the wrist pin. And you'll notice that this is arced out on one side, so it pushes against the piston with something pretty close to, so it doesn't mark up the piston. It's made out of aluminum, but and then I'm going to put this end on there, and then you turn this extractor in. Nope, should go the other way. In there until it starts putting some pressure on the wrist pin, and you just keep turning it, and it extracts the wrist pin. You see it don't turn very hard. The wrist pin's about I'd call it a thumb press fit. You know, in other words, you can put it in there. If you push it real hard with your thumb, it probably will slide in there. A lot of times when I put the wrist pin back in, I will use heat this up in a oven or maybe a torch or something, just to get it warm enough to where I can barely hold it in my hands, and just that much heat's enough to make the wrist pin slide right in there. So there you go. Now once you do that, like I say, it's a left-hand thread. It's awful hard to remember that. And there is the wrist pin. Now you'll notice, and this is the part that's going to scare you, a whole bunch of needles come out of there for the needle bearing, and you have to put them back in there with grease, and I use a special tool which I'll show you later when I put it back together, and that's how I get that back together. But all that stuff is going to fall inside the piston. There's a couple little spacers in there too that, you know, center the piston on there, I guess. But I got one more needle. There we go. Now the other thing I'll show you, I don't know if it'll show up on there or not, you'll notice all that carbon in there. Okay, let's see if I can see. I guess you can see pretty well the carbon that's in the bottom of this piston. This is where you get carbon with an inverted engine, because whenever you shut it off, all the gas and oil eventually runs down into the back of the side of the piston here, and because the piston's hot, it's going to cook in there, and you're always going to get a buildup of carbon right there. But it comes out pretty easy. You can push it out of there with a screwdriver and kind of clean it up. It's not that hard to get off there, and it's no sense getting it real clean because it's going to get carboned up again anyway. But anyways, that's what I do to get it off. Now this piston, this is the one off the PTO side where the drive comes from. It's the same way. It's stuck on this one side just a little bit, but it's not too bad. In fact, the second ring on it now looks, it's stuck a little bit yet. This one's still stuck. It was time to take it apart. If I kept going with it, sooner or later it would seize up on me because the rings are not sealing anymore, and that makes the piston even hotter. I think the top ring was doing fine, but you know, you really need two rings. Two rings gets rid of heat better. Three rings would be better, but it's going to make more drag on the piston, and the engine isn't so efficient, and it puts more wear on the cylinder too. So most two cycles will just have two rings on it. They don't need an oil control ring because they burn oil all the time anyway. So there you go. That's what there is to getting the piston out, and I do the same thing to the other one. And I usually leave one snap ring in there. This one's still in there on this side, and the reason I do that is I know that piston goes this way then towards the PTO side. That's the way I took it out of there. So by leaving one snap ring in, I always know which way that piston goes in there. Now sometimes they'll have arrows on the top, but you got to get all this carbon off to be able to see them. And if there's an arrow, usually the arrow points to the exhaust side on where the exhaust port is. There'd be an arrow pointing that way. But I don't know if Rotax has that or not. I'll have to get it apart to see. But once I get it polished up, I'll see what's on there. If anything's written on there, something's written on it for sure. They usually do. Okay, and then I'll be able to show you the modifications. Once I get this bottom half of the case off, I'll be able to explain what it was I did about this shaft, and which is what all this is about, is telling you what I got to do to show you where this modification is. The fellow that had the engine before me, he put a new shaft in there. I think they reduced the diameter, I think, is what they did. Where this water pump went on, they made it smaller. I think this right here was where the seal was running against, and I think the change was that they made that smaller, and that update helped keep the seal from leaking so easy, I guess. I think that's what the idea was. I don't see any seals in this that show any evidence that they've been leaking at all. It's 20 years old and it's got a lot of hours on it, but everything seems like it's working just fine in there. I don't see anything wrong with it. Not so far. Maybe I'll find something, but so far it's all right.